Good morning, afternoon or evening, depending on when you're watching this video. Today's lesson is going to be talking about molar volume. Maybe sounds a little bit complicated. It is a new concept for higher chemistry. However, I'd like to think quite an easy one, definitely easier than the previous thing that we looked at, Avogadro's constant. So the molar volume basically means the volume of 1 mole of gas. That's it. So basically the volume that 1 mole of gas would occupy. The amazing thing about this is regardless of what gas we speak about, so we could be speaking about hydrogen or 1 mole of hydrogen, H2, which weighs only 2 grams. Or we could be speaking about 1 mole of oxygen, for instance, which weighs 32 grams. Or 1 mole of carbon dioxide, which weighs 44 grams. So regardless of what gas we're speaking about, in gas state, they always occupy the exact same volume. And that volume is, roughly speaking, depending on pressure and temperature, that volume is somewhere around 24 litres, give or take. This number is always given to you in the question, so it's really important that when you're doing these calculations that you're looking at, it's usually ask the question and then it tells you take the molar volume to be, and then it gives you a number, but it's usually around the 24 litres. This basically means if I had 1 mole of hydrogen, it would take up 24 litres, quite a big space. If I had 1 mole of oxygen, exactly the same. So regardless of what gas we're talking about, because the particles are so far away, they occupy, so the weight becomes a bit irrelevant and they occupy the same volume. What we're going to be looking at is a couple of questions on how to use molar volume. So the first one that we're going to look at is we're going to try and calculate what the volume of oxygen is needed to burn 3.12 grams of benzene. And this time, as I was saying previously, take the molar volume to be 24 litres per mole. This time it very much is on 24 litres. So the things that we're interested in is asking us to calculate the volume of oxygen. So this is something that we definitely are needing to be interested in. Is needed to burn 3.12 grams of benzene. This is something that's given to us. So I'm going to put a little tick on top of benzene because this is something I know. So I'm only working with these two things, and because it's just these two, I'm going to divide my page as such, so I can see clearly this side of the calculations and this side of the calculations. Before I make a start with these, we always need to make sure that we've got a balanced chemical equations. 6 carbons before the arrow, so I'm going to need to put 6 carbons after the arrow. We've got 6 hydrogens, 3 times 2 is 6, and then I have a total of 12 hydrogens plus these other 3, so that's 15 hydrogens altogether. So I need this side to be 15 as well. So 7.5, 7.5 times 2 gives you 15. So this is now a balanced equation. The first thing that we should notice is that 1 mole of benzene needs to react with 7.5 moles of oxygen. This is the mole to mole ratio for this equation. Every time I've got 1 mole of benzene, I require 7.5 moles of oxygen. The next thing to do is to work out the formula mass of benzene. So C6H6, as we've done this loads of times, carbon weighs 12 and we've got 6 of them. Hydrogen weighs 1 and again we have 6 of them. The total of this comes to 78 grams. So basically I'm saying that 1 mole is equivalent to 78 grams. This question, the new thing about this question is that it's asking about mass and volume of things. So we need to make sure that we're working in volumes when we're talking about oxygen. This is the gas that we're discussing. So this time, because we've got 7.5 moles of this, we're trying to work out the molar volume. We're trying to see how much space this is occupying. The question tells us that take the molar volume to be 24 litres per mole. I have 7.5 of these. So 7.5 or 7.5 times 24 litres gives us 180 litres. So this means that if I had 78 grams of benzene, I would require 180 litres of oxygen. I then go back to the question. The question didn't ask me about 78 grams. It was asking what would happen if we burnt 3.12. So what I need to do is take this number down to 3.12. So I know that when I had 78 grams, a huge amount, 180 litres was required. With 3.12, this number is going to reduce massively. So to make this number smaller, I take this number, 180, and I make this number smaller by putting the smaller number at the top, 3.12, divided by 78. Basically, that means it's this fraction of 180. And if we were to do this in a calculator, you should have an answer of 7.2 litres of oxygen. So this being our final answer. I'm also going to look at one more type of question that could we could be asked. This time we're going to try and calculate the mass of something using volumes as well. So this question reads, what mass of water is produced when excess cyclobutane burns in 6.72 litres of oxygen? Take the molar volume to be 22.4 litres per mole. So the conditions must have been changed where this molar volume has changed slightly. Remember, temperature and pressure can affect the molar volume. So the molar volume this time is 22.4. This question, I feel, is a little bit trickier because it's mentioning three things in the question. We need to be a little bit smart about this and figure out what things are actually important. So the first one, what mass of water, it's asking us to calculate something. So I'm going to put my question mark on top of H2. It's produced when excess cyclobutane burns in 6.72 litres of oxygen. This is the thing that I know. I'm going to put a little tick on top of oxygen. Where it's saying about excess cyclobutane, this is basically means that we've got plenty of cyclobutane. This is not going to run out. It's the oxygen that decides how much CO2 and how much H2O we're going to produce. If this doesn't make sense, that's fine. Just as I said, try and underline or tick the things that the question is clearly asking you to do. So the question tells us that we have this much oxygen. How much water am I going to produce in these type of questions? So again, what I'm going to do is divide my page between the tick and the question mark so it makes it clear to where the calculations are happening. I also need to make sure that it's a balanced chemical equation. 4 carbons, so I need 4 carbons here. I have 8 hydrogens, so I'm going to need 8 hydrogens, 4 times 2. And I have a total of 8 oxygens, 4 times 2, plus these 4, so that's 12 altogether. 6 times 2 equals 12. So that's the balanced equation just now. So these, as I said, are the things that we are interested in, the H2O and the oxygen. I'm going to write down the mole ratio. So I know so far that every time I have 6 moles of oxygen, I will produce 4 moles of water. The slightly different thing about these type of calculations is that we're working with volume and mass at the same time. So we need to make sure that we've got our wits about us and make sure that we're aware that this is what we're trying to do. So it's saying to us that the oxygen was in litres and we've got 6.72 of that. However, before we move on to this, we know that we've got 6 moles of oxygen would produce 4 moles of water, and every 1 mole is equivalent to 22.4 litres. So 6 times 22.4 equals, did this earlier, that's 134.4 litres. So if I have 134.4 litres, it will produce 4 moles of H2O, or in other words, we can work out the mass. So H2O, hydrogen weighs 1, and we have 2 of these. Oxygen weighs 16, so a total of 18. 18 times 4, as we've got 4 moles of H2O, comes to 72 grams. So I'm just going to write this again a little bit neater. 134.4 litres. So we've now changed the mole ratios into things that we can work with a little bit easier. So 134.4 litres would give you 72 grams. Again, go back to the question. The question wasn't asking about this volume. It's given us the volume, 6.72. So if I had 6.72 litres, what would happen to this mass of water? What would happen to the 72? Obviously, this number we're going to try and make smaller. 134 litres produce 72. 6.7 litres is going to produce quite a bit less. So I'm going to make 72 smaller by putting the smaller number at the top, 6.72, divided by the bigger number at the bottom, 134.4. And if we were to do this in a calculator, you would get 3.6 grams of H2O. This being our final answer.